Welcome back. Today we are really tearing into a stack of professional practice material, the kind of stuff that, doesn't win design awards, but it absolutely determines if a project sails smoothly or, well, if it sinks.
Sinks is a good word for it. We're
hmm
talking about sinking in a swamp of liability, delay claims, and just endless RFIs.
Exactly. We're doing a deep dive into the professional practices issue, project management, PjM 18, document management, and BIM execution plans. And we're really focusing on how file structures, model protocols, and version control play out in real life.
Yeah, this is the unsexy stuff that saves projects. That's
Yeah.
the best way to frame it. Because what we're really tackling here is it's information overload.
It's constant. It's a tidal wave.
It is. And the mission, the absolute core mission, is to make sure that when someone says the model, we're all talking about the same thing.
Yeah.
Not five competing rumors scattered across, five different desktops.
Right. So the goal here is to show how a really well-structured system, a common data environment, or CDE, and a BEP, a BIM execution plan that's actually enforced, can turn that chaos into something predictable.
Into enforceable workflows. And that maps directly back to the big PGM goals. Project execution, quality control, and this is key, coordination procedures that can actually stand up to scrutiny later on.
So this isn't just about being organized for the sake of it. This is about professional standards, standard of care, and ultimately risk.
It's all about risk mitigation. Defensibility, that's the word we'll keep coming back to.
Okay, so let's start there. Let's reframe this whole idea. Why is document management so much more than just filing?
Well, if you still think it's just filing, you're fundamentally underestimating the risk you're carrying. I mean, it's not filing. It is risk control,
Okay.
it is schedule control, and it is scope control, all three.
So as a PM, how do I see those three things play out just from having good file discipline?
Okay, take schedule control. Let's say your mechanical engineer spends, I don't know, 3 hours just trying to find the latest reflected ceiling plan from the architect.
That is all the time.
All the time. That's 3 hours of schedule slippage. Now multiply that across 20 exchanges over the life of the project. That's real delay. Or take scope. 6 months from now, the team realizes the structural model they linked had unverified data in it.
Oh, no.
And now the foundation scope has changed. That's scope creep, fueled entirely by poor version control. So good document management, it just reduces uncertainty. And uncertainty is the enemy of the schedule and the budget.
So you're basically creating a digital anchor. When everything's moving a million miles an hour, the CDE is the one place where truth is established and held still.
Precisely.
Yeah.
And that brings us to what we call the 3 pillars of project defense. Because the moment a dispute arises, and it will, the lawyers and the insurance adjusters, they don't care about your design intent.
They care about the audit trail.
They care about the audit trail. So what are those 3 verifiable items you need to survive that scrutiny?
Let's lay them out. What's number one?
Number 1, the absolute bedrock. A clean version history. You must be able to prove exactly what version of a drawing or a model or a spec was active on any given date. Not just the file name, but the system's time-stamped history.
Okay, that seems doable with today's systems. But what about getting it to people, the distribution part?
That's pillar number 2.
Right.
A clear issuance log. It's not enough to know the file existed. You have to prove when you send it, who you send it to, the GC, the city, a specific consultant, and under what revision status. This is you proving you fulfilled your contractual duty.
Okay, version history, issuance log. What's the third one? You said it's often overlooked.
And it's the one that causes the most damage. It's proof that the team relied on the correct contractual set.
What do you mean?
I mean, proving that the contractor was building off the CO1 published set and not, say, an unofficial WIP screenshot someone emailed them, or a drawing they downloaded from an attachment 2 weeks after you sent the official one.
Ah, and the difference between those two is everything.
It's the difference between winning and losing a claim. The moment you can't prove which PDF the contractor was pricing, your defensibility just crumbles. The liability snaps right back to the design team because you failed to control the distribution of your own work product.
So when things go sideways, memories fail, but the audit trail has to survive.
The audit trail is everything. That's the whole purpose of these protocols, to create that undeniable, time-stamped, third-party verifiable record.
Okay, so if the audit trail is our defense, then the BIM execution plan, the BEP, that's our offensive playbook.
That's a great way to put it. It's the document that specifies the how. Who does what, when they do it, how they submit it, and what standards it has to meet.
But we need to be clear here. How is a BEP different from, say, the contract exhibits, like the AIA digital practice documents?
Great question. The BEP defines the workflow, the process. How we use the software, the file naming, the exchange schedule. But the contract exhibits, like the AIA's G203, they define the authorized uses of that digital data. They set the legal expectations.
Can you give an example of how they work together?
Sure. The contract might say the contractor is prohibited from using the native Revit model for fabrication. That's the legal line in the sand.
Okay.
The BEP then has to operationalize that. It will specify the protocol to support it, like saying all formal model exchanges will be in IFC format only, with an LOD 300 disclaimer. The BEP makes the legal intent real.
And we should probably mention the specific form here, the AIA's G203 2022 BIM execution plan. It's the industry standard template designed to codify all of this.
Right, and it leads to this professional mindset rule that every PM should live by. If a process isn't explicitly defined, agreed upon, and communicated, it's not a process.
It's a future RFI.
It's a future RFI, or worse, a future claim. You cannot manage expectations you haven't defined. Ambiguity is the single most expensive thing on a project.
Okay, so let's dive into the environment where all this happens. The Common Data Environment, or CDE. This ISO 19650 standard has really changed the game.
It really has, because a CDE isn't just a fancy file server. Its core idea is to separate information not just by who made it, like architecture or structure, but by its status.
And why is status so important?
Because status controls reliance. It's how the team knows what's just preliminary and good for coordination versus what is final and can be contractually relied upon for, buying steel or pouring concrete.
I really like the analogy you use, the 4 locked rooms.
Yes.
It makes this abstract ISO thing feel very tangible. Can you walk us through those 4 rooms?
Absolutely. And we use the numbers 01, 02, 03, 04, because that's how they're set up in the real world. The number dictates the hierarchy.
So room 1.
Room 1 is 01 WIP, work in progress. This is the messy, creative, internal drafting space. It's the sandbox. It's where the team is saving, syncing, trying stuff out. And the critical point is, this stuff is not for reliance. It's not for coordination. It's unstable.
So if I link to my structural engineer's WIP folder,
You're linking to something that might be deleted or completely wrong in the next 10 minutes. And if something goes wrong later, the liability is on you for relying on unverified data, assuming the BEP forbade it.
got it. So what's room 2?
Room 2 is O2 shared. This is the first quality gate. Information moves here when the authors say the structural lead has reviewed it and declared it stable enough for other teams to link against and clash with. It's coordination ready. It's a promise that says this is what we know today.
So this is the folder that gets used every day for coordination.
That's your daily workhorse. Then you get to the really high stakes room. Room 303, published, issued.
This is the official stuff.
This is the official contractual stuff, the CD sets, the permit submissions, the bid documents, the ASIs.
Right.
This is information that has passed the formal PM gate and is now legally defensible. The moment a file lands in 03 published, it carries the full weight of your professional standard of care.
And the final room.
Room 4 is 04 archived. Once a published set is superseded, like CO2 replaces CR1, the old CO1 moves here. It becomes the frozen, untouchable historical record. You never, ever delete an issued record. You archive it. This is your ultimate protection in a dispute.
And what's interesting is that this isn't just some abstract theory. Platforms like Autodesk Construction Cloud, BIM 360, they are literally built around this ISO 19650 structure. The numbered folders are there to mechanically enforce this workflow.
That mechanical enforcement is the key. You're designing the environment to make the right choice, the easy choice.
Okay, so let's talk more about that enforcement. A file structure has to be 3 things to really work.
Simple, enforced, and permissions-based. I've seen so many firms create these brilliant, 12-layer deep folder structures that are so confusing the team just gives up and saves everything to their desktop.
Which defeats the whole purpose.
Completely. Simplicity reduces human error. But enforcement through permissions, that's what eliminates the possibility of critical errors.
Let's get specific on those permissions for each of the 4 rooms. This is where the PM really takes control.
Okay, for 01 WIP, write access has to be super restricted. Only the discipline team that owns that data can write to it. Everyone else, locked out. Or at the very, very best, maybe a read-only for a specific QA role. The rule is, if you don't own it, you don't touch it.
That immediately cuts off that sloppy link risk we're going to talk about.
Instantly. Next, O2 shared. Here, everyone needs read access, right? The whole team needs a link to this data, but write access, that's restricted to the discipline leads only.
So a junior designer can't accidentally publish a half-finished model to the whole team?
Precisely. The lead is the gatekeeper. Now, the most critical folder, O3 published. Right access here is for the project manager or designated admin staff only. Period. No designer, no consultant lead. Nobody else should ever be able to upload a file there.
So the PM becomes the single point of control for all contractual information going out the door.
Yes. They're the one ensuring it has the right revision stamp, the right transmittal log. If the integrity of that published folder is compromised, your liability is through the roof.
And O4 RCIV.
Strictly controlled by the PM or admin, should be read only for pretty much everyone. In a lot of setups, it's not even visible to most users, just to prevent someone from accidentally linking to old data. It's the project's safety deposit box.
That is the power of permissions. It's not about being difficult. It's about enforcing professional integrity.
Exactly. Okay, so now let's look inside those status folders. You can't just have 1,000 files dumped in O2 shared.
Right, you need layers.
You layer by discipline codes. This is standard stuff. ARCH, STR, MMEE, and so on. It makes everything instantly searchable and clear.
What about for really big, complex projects?
For something like a huge hospital or a multi-tower project, you might add another layer for zones or phases. Area, phase 1, it just breaks down the complexity.
But the real metadata, the most important stuff, is encoded in the file name itself. Let's talk naming conventions.
The goal here is that the file name has to tell a story, so a person or a piece of software can sort it without guessing. It's a core ISO IA 650 principle.
Okay, let's break down that practical example from the source material. 2407 ADR-02 1150 PO3.PDF. Walk us through that.
Okay. 2407 is the project ID. A is for architectural. DR is the type code for drawing. 02 means it's for level 2. 1150 is the unique sheet number.
And the most important part.
The final part. P03, that's the revision code.
Huh?
And that P ties directly back to our CDE rooms.
Let's spend a minute on those revision codes because that's where the legal stuff really comes into play.
Right. We have type codes like DR for drawing, MDL for model, SPC for spec. But the revision codes are what manage risk. We have to distinguish between preliminary codes.
The P codes.
Right, P01, P02, which are for internal use and coordination in the O2 shared folder. And then you have contractual code, the C codes, starting with C01, which signify a formal contractual issue from O3 published.
So what happens if a PM accidentally sends a file named PO3.PDF to the contractor instead of the CO1 revision?
That creates instant damaging ambiguity. The contractor could argue, well, I saw the P and assumed it was preliminary and unreliable, so I ignored it. Or worse, they treated it as contractual because it came from the published folder. If there's an error in that PO3 file, you have no defense. The BEP must be rigid. Only files marked C are for construction reliance.
So we have the folders, we have the file names. Now let's talk about what happens inside the models. This is where the BEP acts as a kind of coordination contract.
It absolutely is a contract.
Yeah.
Because all the models, architectural, structural, MEP, they all have to be speaking the exact same spatial language. And that starts with coordinates and control.
A topic that gets glossed over way too often.
And it can ruin a project before you even break ground. The BEP has to state unequivocally who provides the survey data, what is the single shared coordinate system, who is the owner of that origin point. If 3 teams are working off 3 different origins, you have 3 different buildings.
Which brings us to what you call the #1 avoidable mess, link rules.
The primary rule here is non-negotiable. Models must be linked from shared or consumed locations only. That's the only place the data is stable and verified.
So what are the things you have to explicitly ban in the BEP?
Ban linking to personal desktops. It's a no-brainer. But more importantly, you have to explicitly prohibit linking to someone else's WIP folder. As we said, that's linking to an unverified, unstable, possibly experimental file. It's a professional failure waiting to happen.
Okay, let me play devil's advocate. What if an engineer needs to run a quick check? They know the architect just synced their file, and waiting for the formal shared publish is going to cost them a day.
And that's exactly where the liability trap is. That judgment call is what the BEP is designed to eliminate. The time you think you're saving is never worth the risk you're introducing. If the team needs data faster, the BEP needs to enforce a more frequent publishing rhythm, not encourage people to break the rules.
What about performance? Big models get slow. Sometimes you have to detach links.
The BEP should have a performance clause for that. It can permit breaking links for performance, but it has to be logged. And the model must be relinked from the authoritative shared package before any kind of publishing happens. It makes it a conscious, documented choice.
Can you walk us through the proper workflow in a platform like ACC? It's more than just copy-paste.
It's a critical gatekeeping process. First, the architects will publish their model from their WIP space. Then they package and share it with specific teams. The structural team then has to consciously consume that package. Only then do they link from that consumed location.
Why all those steps? Publish, share, consume.
Because every step is time-stamped in the audit log. The PM can see the architect published at 9 a.m. and structural consumed it at 11 a.m. It enforces accountability. If the structural team fails to coordinate, the log proves they were working off old data.
So let's talk about that rhythm. How do you define the difference between a sync and a publish?
Async is just saving your work. A publish is a formal communication event. The BEP must define a minimum frequency, like every discipline publishes daily by 4 p.m.
And what about major milestones?
For those, you have model freeze dates. At DD or CD, the model is frozen. No new geometry goes in until the review is done. You can't have the contractor pricing a model that's secretly changing in the background.
And maybe the biggest liability protection in the BEP, defining level of development and level of information, LOD and LOI.
This is so critical. LOD defines the geometric reliability. Can you trust the shape and size? LOI is the data attached to it. The BEP has to define these by phase.
Give me the high-stakes scenario here.
Okay, your structural model is LOD 300 at DD. That means the size and location of a beam are reliable, but not, say, the bolt hole details. If the BEP is silent on this, and the contractor uses that model to generate fabrication files.
Which are LOD 400 or 500.
Exactly. And a connection detail is wrong because it wasn't fully developed yet, liability skyrockets. By stating in the BEP that the model is LOD 300 and not for fabrication, you limit your professional responsibility. You have to state what is in the model and what is explicitly out.
And before any of this gets published, there has to be a QA/QC date?
Non-negotiable internal checks. We call them model health checks. You resolve warnings, check for unplaced rooms, make sure view templates are right. Publication has to be conditional on passing these checks.
And clash detection.
The BEP has to define the scope. Who runs the reports, how often, and how are issues tracked and resolved. It turns conflict resolution from a shouting match into an accountable workflow.
Okay, let's take all this theory and smash it into the messy reality of a project. Let's dig into that case study about the hidden cost of one sloppy link.
Right, this is a very real-world scenario. It's an 8-story mixed-use building, tight urban site, fast-track permitting. The team is using Revit, Civil 3D, all on an ACC cloud platform. So, high complexity, high risk.
Describe the disaster. It's the D&D deadline. Everyone's rushing. What happens?
The structural engineer had formally sent a coordination package to the shared folder 2 days earlier. But right at the deadline, the project architect, wanting the absolute latest file, links what they thought was the latest structural model, and a major grid line of columns has shifted by a full 2 feet.
Oh, that's a nightmare. The entire architectural layout is suddenly wrong on 6 floors.
Total panic. An emergency meeting is called. And what's worse, because the communication was just a panic email chain, the contractor who's actively pricing the steel gets copied on it and starts pricing massive unnecessary changes based on this new column location.
So within hours, you're behind schedule and potentially looking at a huge, completely phantom cost increase.
Exactly. A $50,000 variance, potentially, all based on a rumor.
So when the PM finally did the post-mortem, what was the root cause?
It was a direct BEP violation driven by pressure. The architect bypassed the controlled consume workflow and linked directly to the structural WIP folder.
Ah, they went into the sandbox.
They went into the sandbox.
Yeah.
And that WIP folder contained the structural team's latest unverified sync. It had an experimental column adjustment that a junior engineer was testing but hadn't validated. The correct authorized model was sitting right there in the structural shared package untouched.
So it's not that the system failed. A person failed to follow the system because they were under pressure.
That's it, exactly. The rule was clear. Never link to WIP. But the human instinct was to grab the newest file. And that one choice cascaded into a schedule and financial disaster.
Okay, this is the most important part. The standard of care response. What does a competent PM do right now to fix this?
It has to be a calm forensic checklist. Step 1, stop the bleed. Control the reliance. You send a written communication to everyone, especially the contractor. WIP is never for reliance. Coordination must use the authorized shared packages. You have to pull the contractor out of that alarm cycle immediately.
So you fix the source of truth first, not the design.
Correct. Step 2, audit the CDE trail. You use the platform's history logs to find exactly which file was linked from which folder at what time. You get the forensic proof. Then you pull the correct shared package and rerun coordination to confirm everything is actually okay. You have to achieve certainty.
Then step 3, the coordination bulletin. Why a bulletin and not a drawing addendum?
Because the design intent never changed. This was a communication error, not a design correction. So you send a short, formal memo explaining the mix-up, identifying the correct model location, and fixing the data stream without triggering the formality of a full drawing revision.
Step 4 is the systemic fix.
The permission fix. You lock the system down immediately, you change the folder permissions so this can't happen again. You make the WIP folder invisible or read only to other disciplines. You remove the human choice from the equation.
And finally, step 5.
The process fix. You update the BEP itself, maybe even reference this incident as a lesson learned. You add a big, bold rule. Links must reference shared consumed only. And you reestablish that weekly model package cadence to eliminate the excuse for going into WIP.
Okay, we've seen the panic and confusion, but let's actually quantify the cost of that one sloppy click.
Because that time spent untangling the mess is real billable time.
Let's run the numbers from the scenario. We had 3 people, a PA, the PM, and a designer, each spending 4 hours on damage control at a blended rate of, say, $140 an hour.
And don't forget, that slip forced an emergency consultant coordination call just to verify the coordinate system wasn't compromised. That's another $900.
Okay, so internal labor. 3 people times 4 hours is 12 hours. 12 times $140 an hour is $1,680.
Plus the $900 for the coordination call.
The total avoidable impact from one click is $2,580.
Wow, over $2,500 just gone instantly because someone didn't follow the BEP.
That's the takeaway, and that number is before you even factor in the contractor's wasted time, the potential permit delays, or just the cost of a stressed out, frustrated team. The BEP and the permissions, they're the cheapest insurance policy you can buy.
To make this stick, let's go back to that conceptual model. The CDE as a one-way valve.
It's a powerful way to see it. You have your 4 boxes in a row,
Yep.
WIP, shared, published, archived, and information can only flow from left to right.
And the rules for movement are what matter.
They only move forward after passing checks. They almost never move backward.
So if you find an error in a published set, you don't just pull it back and edit it?
Yep.
Never. If there's an error in CO1, you leave CO1 in the archive, you create a new revision, CO2, that has to go all the way back to the process WIP, shared before it can hit that publish gate again. And the PM is the one controlling that final gate, ensuring the integrity of the whole record.
Okay, let's shift into the strategy and liability side of this. Let's talk about the value of that status metadata. The PISA one, the CO1.
That revision control, that status, it's all about managing information reliability. It's what turns a draft into a deliverable. It tells you what level of risk you are taking on when you use that file, and it tracks what was shared with whom and when.
Which leads right into managing model exchange risk. Let's do a scenario. A contractor asks for the native Revit model to produce shop drawings, but the BEP says the model is only LOD 300 and not for fabrication. What's the architect's best response?
This is a huge risk moment. The worst thing you could do is just say no, or worse, just send the file with a disclaimer. The best response is to clarify the authorized uses, offer an approved exchange format like a secure PDF or an ISC file, and document the limitations in writing.
So you're protecting yourself against unauthorized reliance.
You have to.
Yeah.
You reference the BEP, you reference the contract. If you just send the native model without forcefully clarifying the LOD 300 limitation, you are implicitly transferring risk to your firm because you provided the tool for them to make an error.
Okay, what about protocol failure? The BEP is great, but people are human. They keep dropping files in the wrong folders.
A BEP that requires perfect human compliance will fail every single time. The solution isn't more meetings or angrier emails. It has to be systemic. It's permission-based folder controls, combined with a simple checklist before publishing.
The system has to enforce the behavior.
The system has to make it impossible to do the wrong thing. The BEP is the rulebook. The permissions are the handcuffs.
All right, let's go to the ethics corner. This is a tough one. A consultant quietly asks you, the PM, to please delete an earlier, bad-issued model from the published folder. They're worried it has an error and could look embarrassing in a future dispute.
The standard of care response here is absolute and non-negotiable. You never, ever delete issued records. Ever. You preserve the history in the archive, you document the correction with a new, superseding revision, and you maintain the issue log.
Why is that so critical? What's the specific risk if you hit delete?
The risk is a legal charge called spoliation of evidence. It's the destruction of evidence relevant to a legal proceeding. Even if you correct the error, deleting the original record implies a cover-up. It undermines your project's entire defensibility. It's an ethical and a legal disaster. Your integrity demands that the record remains intact.
So what's the general strategy for these kinds of questions? What's the core tactic for any document control problem?
The correct answer always involves systemic control and documentation. You establish one source of truth. You prevent reliance on unstable data like WIP. You document every decision formally. And you adjust the process, usually with permissions or a BEP update, to stop it from happening again. If you have two choices, pick the one that reduces ambiguity and creates the most robust, traceable record.
What an incredible deep dive. This really does transform what looks like clerical work into just core risk management strategy. Let's do a final pinup. The three core mandates from today.
First, the coordination role. Never coordinate from WIP. Data must come from shared or consumed, period.
Second, the PM's rule. Published is sacred. It is a controlled, traceable, legal record managed only by the PM.
And third, the legal rule. Logs beat memories. Always rely on the formal issue logs and transmittals, not on recollections or email attachments.
And remember that visual. WIP to shared, to publish, to archive. That one-way flow is the definition of control.
Okay, so for everyone listening, we have a couple of tonight's action items for you. First, sketch out your ideal CDE folder tree with permissions. Where do you, as a PM, need write control? Where do your consultants need read-only access?
And second, write out 5 common gotcha scenarios. A wrong link, an overwritten file, a consultant asking you to delete something, and then script your PM response for each. If you plan for the chaos, you can manage it without panic.
And here's the final provocative thought for you to chew on. It goes back to that low D, low I risk. Let's say your BEP clearly dictates that the structural model is only LOD 300 design intent, not fabrication ready. But the contractor, finding it easier, uses it to detail and build a complex connection at LOD 500. And that connection fails.
The BEP said not to. The model was only 300, but they built 500 from it. So what happens? What liability is created?
That's the question. Does the contractor's unauthorized reliance completely shield you? Or did the architect, by providing the native model at all, implicitly assume a higher standard of care? The fight isn't about geometry. It's about scope and reliance. And that battle is always fought inside the 4 corners of the BIM execution plan you wrote.
A powerful point on the moving boundaries of digital deliverables. Thank you for guiding us through this. This was essential.
My pleasure.
Until next time, keep those logs clean and those permissions locked down.